Hey, Jeremy, how you doing?
Hey, good. How about you?
Oh, doing okay.
Our air
Let's
is
see.
finally clear again here in Seattle, which is awesome.
Oh, that's wonderful news.
Yeah, breathing outside is great.
Excellent. Let's see. Are you signed in as the host,
I am
Jeremy?
not. I can be.
Okay. I'm not getting the prompt to do that, and it is confusing me.
Oh, yeah, I don't see the normal. Oh, I guess I am.
Okay, there we go. So I think if that's the case, you'll need to enable screen sharing for part of this. Might as well do it now.
Yeah, good call.
I also don't. Okay, yeah. I guess this is recorded. Okay, great.
Okay, screen sharing is enabled.
All right, maybe we can give it just a minute more.
Sounds good.
Okay, why don't we get started? Welcome everybody. It is the September 22nd SIG multicluster. Andrew, I think you're on the agenda first.
Yeah, so I know this has come up in the past before, and it was something that was considered in the original CAP, and it was kind of deferred. So I figured, now it might be a good time to talk about what would it look like for the multi-cluster services APIs to support node ports. So basically, I think today, multi-cluster services API kind of assumes that every pod and all clusters are routable within each other, which I think works great if you're using a managed offering or you have a network topology that allows that. I think in many clusters today they're using overlays, and the only assumption you can kind of work with is that the nodes can connect to each other, but pods themselves have to go through the nodes to connect to each other. So basically, like, I'm thinking about workflows around if I have a service type node port and I point a service export at it, should there be some field in service export that says export the node ports and not the pod IPs, or should there be like an explicit binding between the type of the service and the service export? So I'd love to discuss how to make exporting node port services possible.
Yeah, that one gets really interesting, right? I think so. So your initial suggestion is something like optionally export a node port, like node IP and port, instead of the pod IP, right?
Yeah.
Yeah. So node port gets really complicated because I think there's a few assumptions with node port, right? Like obviously between clusters, coordinating a node port is tough. And then I think in something like what you're suggesting could work in a basic case, but there is no guarantee of correlation between nodes and pods, right? So then, if you look at the way an imported service is consumed, that would give weight to a cluster based on the number of nodes, right, instead of the number of pods. Oh, Tim, the question is multi-cluster service, node port service.
Yeah, I think like the first question I have even before that is like, if we did want to support this, should the node port export happen implicitly based on the type of the service that we're trying to export? So like, should service type node ports automatically be exported as node port? I don't think we want that, but that's one option. And the second option would be like, should there be an explicit field in service export that says, if this service is a service type node port, export the node port addresses and not the pod IPs.
Can you say what you're trying to do, Andrew?
Yeah, sorry if it wasn't clear. Basically, like in an environment where pods aren't routable, right? Pods need to connect to each other using like the node network, and so one way to do that is with node ports. So how do we have the multi-cluster services API support node ports as like the actual endpoint / addresses that get imported across clusters?
I see. That's an interesting question. So if I can step back for a second, typically, it's a little bit vague, so I'm going to wave my hands a little bit, although you can't see me because my video is off. There's the distinction between north-south and east-west, right? And pod IPs and cluster IPs are the sort of east-west lane, and node ports and load balancers are the north-south lane. So if we start going into node ports, we're opening the can of worms to, well, does that apply to load balancers too? I'm not saying we shouldn't, but I think we should tread carefully because it's different. And we know with the proliferation of external traffic policies and all those other things, like it's a slippery slope once you start dealing with the north-south side. And I regret all of the APIs we've added for that.
Yeah, I definitely agree. I guess my next question for that would be, in clusters or network topologies where the pods aren't routable, like today, like the multi-cluster services APIs wouldn't work, right? So what are the alternatives if not with node ports? Like I see the other alternative being export the nodes and their ingress ports, like assume the nodes have, an ingress controller running on 443, and just export those, but that seems clunky as well, like in terms of what the API would look like. So like, what are the alternatives if if the clusters don't have routable pods?
Yeah.
Go ahead, Jeremy. Go ahead.
I was just going to say, like, I think we've kind of hand waved that away. Basically, if it's up to an implementation then to make the pods routable is kind of the approach that we've taken. I don't know that that's the right approach long term, but like we saw that demo from Cisco a couple weeks ago, where they had a solution to kind of add their own proxying layer. We're going to see a demo of Submariner today, and so like I think there's a couple, like there are options for flattening a network, and maybe the answer is an overlay, and maybe that's not always a good answer. I guess the issues with node port that Tim raised are good ones, but the other one that I have is that by kind of abusing this existing north-south feature for east-west, we're kind of introducing different characteristics. And if we say that this is like the way to do it, the standard way to connect to, partially connected networks or any network where pods are not visible, I worry that we're going to kind of introduce some like de facto behaviors that we don't want in the system. Because node port doesn't really map one-to-one with pods, obviously, and that's going to create some weird characteristics that we need to navigate around.
That's a great point. I hadn't thought about that. Can I add one more point though? Node port and routable are not mutually exclusive. Like node port is used for other things, even when the pods are routable. So it would be an explicit decision if we want to go down this avenue.
Exactly.
that's sort of the question that I had, Andrew, is like, and I won't speculate about like your encompassing use case. So I'll ask instead, is the interested node port a case of I have a thing, it uses node port, it has to use node port, or is the motivation like I think I should use node port because of X or Y other thing? So is it a question of like absolutely positively has to be node port, or maybe node port might seem like a convenient mechanism to use? Does a distinction make sense? And does the question make sense?
I think so. I think there's nothing forcing node ports. The only restriction is that we don't have routable pods and clusters. And I think that's a pretty fair assumption to make in many environments. And given that service type node port seems the most, like the lowest friction way to do that. So that's where I'm coming from.
Yeah, that's what I got from you as well, is this is about making pods visible using a mechanism that already exists, not specifically using node port.
Yeah.
So if again, in the abstract, I'm going to hand wave, we're using node ports as a gateway of sorts, right? An entry point into the cluster, but they're not the only hypothetical such thing, right? I could stick a proxy, I could stick an ELB in front of my cluster that spanned two different VPC networks, right? And that doesn't, it behaves like a node port. It may actually be implemented in terms of node port, but it's not literally a node port. And I think it's reasonable for us to think about how to represent some form of gateway here. In fact, we've got this gateway API. I don't necessarily want to couple these two ideas, but they seem like they might be well aligned. But the other part is that we'll need to carry some notion of like capacity, right? Like this one IP port represents 100 pods.
So another question, which is related, is it seems like a lot could hinge on the specifics of the use case about is a motivator to have a service be externally available, or is the motivator to have pods in cluster A address a service in cluster B? So is it external to the cluster set or internal to the cluster set, or both? It seems like a lot hinges on that, and it might be worth decomposing into those specific permutations, if so.
Yeah, I think I was referring to internal to the cluster set, which to me, like, so like regarding like east-west, north-south traffic, to me, I agree that load balancers are typically like north-south, but I've seen node ports used for east-west quite a bit. Sorry about the screaming baby. And so like to me, like naturally, like having node port for internal to a cluster set makes sense.
Yeah, Andrew, I'm not disagreeing. My point about north-south was that's what node port was traditionally used for. In this point, I agree with your characterization, but because of the shape of it, it doesn't fit well. And so I think I'm not against it. We just need to think really hard about how we want it to behave.
Yeah, maybe another way to look at this is how do we just address, like there is a very clear need to address partially connected networks or networks where the pod is not visible for east-west. And you know, node port aside, like that seems like something that needs a solution.
Yeah, I agree. Yeah, maybe the question is better phrased as just how do we address not routable clusters?
Yeah,
or not.
And it gets arbitrarily complicated. It gets ridiculous because I could have 3 clusters on one VPC and 3 clusters on another VPC, and I need a different mapping depending on who's talking to who.
Right.
I'm going to link a slide deck that I wrote a while back just on this topic, just for context, in case I ever use these words, people can browse it.
Awesome. Yeah, thanks, Tim. Yeah, because this has come up a couple times, I think. We started with the simple case, which is all the pods can be seen, but it seems like with this, we're going to need to solve some kind of way to represent multiple pods in another cluster behind a single endpoint without messing up waiting. And sorry, Paul, I see your hand.
Oh, no problem. Are you done?
Yeah.
I was just going to wonder aloud whether like the Cisco implementation that we saw would address this. And similarly, I'm wondering whether the Submariner implementation that we'll see later today will address that.
Yeah, I think like with the Cisco implementation, it certainly seemed to address part of this for sure, or maybe it addressed this problem. I think there were some other things that needed addressing there as well, but yeah, it was solving this use case, and Submariner may as well. So maybe like I'm very much looking forward to seeing the Submariner demo. But maybe the answer is like, here's a couple projects that implement MCS for disconnected clusters or partially connected clusters.
So are we saying that this is an implementation detail of the API and there shouldn't be anything in the API that makes that assumption?
I don't want to make that statement because I feel like this is a common enough use case. And I'm certainly in general not against making changes to the API if it's not solving needs, of course, like it needs to be useful. So, but maybe a different question is, what are the common use cases? Like what are the common needs of these solutions? Like, is there a common way that we need to extend the API to make it easier to implement these disconnected solutions, partially connected solutions? Maybe that's a better way. Like, we probably don't want to steer the API to always so that you always have to care about this, if you do have a flat network, but the API needs to work for partially connected networks.
Okay, that makes sense.
I'm having a little audio trouble, so let me know if you can not hear me. I think if we're going to solve this, we will need to look at how to expose this explicitly, something like this. Like specifically expose this service, but use this gateway to get there, where the gateway may be all of the node ports in this cluster, or this load balancer, or this VIP. And we need to figure out where that information comes from. And given like an archipelago model, which we've seen a lot of customers build, we need to make that contextual. So I don't know where that information comes from or what it looks like, but I think sort of that's the turtle at the bottom. What is the mapping? If anybody knows the ACPI, it's like the system locality information table, a two-dimensional table of the cost metric from X to Y for all X and all Y.
Yeah, that makes sense. Okay, thanks.
Should we start a doc and just start throwing some ideas in there, or use cases? And it'd be great to have like Submariner folks chime in too on issues they've run into. But it seems like this is going to need to be a more involved conversation for sure.
I think that's a reasonable thing to do, to start collecting stuff.
Yeah, I can start like a Google Doc and just start collecting use cases and go from there.
Awesome. That'd be great.
Okay, it sounds like we're talked through. Why don't we proceed to the Submariner demo, if folks are ready for that.
Yeah, I'm ready. Let me share my screen. Let me know once everyone can see my screen.
Looks good.
All right. Okay, I believe we've already given demo of just Submariner without the service discovery in the MCS API implementation part of long time back. So in this demo, I'm mainly going to focus on the MCS API implementation that we have done. So what I have over here are 2 clusters. This is all running in a kind setup. I'll share instructions later on with the slide deck, like how you can bring it up. It's real simple. You just clone a repo and run make deploy, and it will set up a kind cluster for you to play around with. Okay, so I have cluster 1 and cluster 2. This is shell is my netshoot pod running in cluster 1. This is from where I'll be trying to access the services that I'll be creating in cluster 2. Okay, so let me just pull up stuff quickly. So this one, I'm creating a stateful set with the headless service backing it in cluster 2. So we'll just wait. So the pods are coming up and they're up. Okay. So this is over here. If I try to access, it will not work because I have not exported the service yet. Okay. So that's all fine. And then I just export the service, which creates us. So Subcontrol is Submariner's own CLI, so we just made it easy to create service exports. You can also manually create a YAML and export it with something like this. So the service export has been created. Let's see. Which also creates service imports.
Could you bump the font size up on the terminal, please?
Yeah, sure. Just give me a second.
Thank you.
Is this good? Maybe bump all things a bit. Yeah. Okay, and just one quick thing. The way we do things in Submariner, we don't have a central MCSD controller. We have like a broker kind of architecture which acts as a data store, and it's like every cluster distributes the resources that's on it to everyone else. So that kind of model. We don't have a central MCSD controller that is doing all this distribution. Okay, so now that the service import has been created, if now I try to dig that, so you can see IPs of both the pods backing up are showing up over here, which we can see from. See, so both the pod IPs 1284 and 196.4. These we can show up in our dig response. And now let's try accessing one of the individual ones using web 0.cluster2. And it only gives web 0. When I do web 1, it should give only web 1. Okay. So this is it. So I use a headless service example because it's easy to show, like we are able to create individual pods. Similarly, let me just create a cluster IP service also just for completion's sake. And I create this. It's created the cluster IP service. It should show up here pretty soon. Yeah, so the pods are up. I'll export it. Export the service. And now if I try dig, it returns. Okay, so this is one difference that we have in Submariner with the MCS API, because remember, Submariner has been going on for almost a year and a half, and we had this basic Lighthouse service discovery solution before the MCS API was fully, formalized and rather still in the works. So the way we do things here in Submariner and Lighthouse is that actually we don't have a supercluster IP implementation yet, but you get the IP of the individual of the service running in that particular cluster in case of cluster IP service. So if you can see the IP that we got over here is same as the cluster IP of the service. It's 136.205, 136.205. So when you have service running in multiple clusters, it will return one of the IPs in round robin. I can show that too, actually. Let's do that. So I create another of this cluster IP service in cluster 1. Okay, and I need to create a service export for it in cluster 1. Should show up soon. Yeah, it is up. Now if I query this one, you can see it's returning the IPs for both of them in round robin fashion. So that's the one key difference in the AP implementation that we have. So we plan to conform fully to the upstream spec going forward, but it's kind of a work in progress because we already had something working and we were using our own some CRD, which was some rough approximation of what service import was doing at the time. And so this is basically the gist of it.
This is awesome.
So you create service exports, service imports get distributed, and everything is running in each cluster. We don't have a central controller, which kind of adds to the complication of having supercluster IP. So we're trying to figure out a good way, a performant way to do it without having to have a central controller. So this was the demo. Let me just quickly run through the slide deck for those who may not have attended our first presentation when we gave it last time. And maybe at the end of it, we'll have the Submariner. It's an open source upstream vendor neutral project. This is the link to the website, submariner.io. It has documentation on what the architecture is, how you can run it and all that. So the core of Submariner is it provides L3 connectivity between clusters using IPsec with LibResponse, Swarm, or WireGuard. So basically, like you were discussing there, right? Like it provides a flat network connectivity across clusters. So every pod can access every service or pod in another cluster. That's what it does. And it has been designed in a way which is cloud provider and CNI agnostic. Now we say CNI agnostic means it can work with any CNI, but we have not tested with all of them. The ones listed here are the ones we have actually tested with. And I think Sridhar from Red Hat recently did some tweaks which were the testing with Calico and got it working, a few hiccups here and there. So if you have a different CNI, you would like to make it work with Submariner, try it out, raise the issues, or just get in touch with it, and we'll do that for you. And other thing is, idea with Submariner was, okay, people would already have existing clusters that they would like to connect and access service across. So it provides that. You don't need to. It doesn't have to be a new greenfield deployment. You can have existing clusters with your workloads and everything, and you can install Submariner on top, and you'll get that connectivity. So this is some of the top use cases that we had when we were coming up with the design, and something that we have few folks try out this Submariner with service mesh across clusters, stretch databases, where you have multiple database instances running on multiple clusters for availability, apps on edge, and your database on premises. And then one of the key design goals for us was always to use as much as existing resources on the cloud as possible, so that it's able to work in a cloud agnostic manner. So core components, one is the Submariner broker. Like I said, it's the core central component. It can be run on any cluster. It's basically a set of CRDs backed by Kubernetes data. So there are no services, pods, daemon sets, anything running. It's just totally a serviceless kind of architecture. So the way we work is first you deploy a broker in Submariner, and then you join clusters to it. So if you have just one cluster, that will need to join to the broker. And only requirement is those clusters should be able to access the Kubernetes API endpoint of whichever cluster broker is running on. And here you can see, the advantage of having this than a central controller. If you run a central controller, then that central controller needs to have some way to communicate to API endpoints of all the other clusters. Whereas this way, every cluster just needs to talk to one cluster where the broker is running, and things work. So that's why we went with this kind of model. And for the core components, it has two components when it comes to providing network connectivity. First is the Submariner engine. So Submariner has a concept of gateway nodes, which provide that IPsec tunnel between two clusters. And you can set up multiple pods as your gateway nodes, and one of them will become a leader. It will establish IPsec or WireGuard tunnels, depending on what is the cable driver you're using. And it is also responsible for updating your local clusters information to, like what is the cluster CID, what is the service CID, and things like this to the other clusters. That's what it does. And then is the Submariner route agent, which runs on every node. It is always aware which node is the current gateway leader. Okay, and it is used to route traffic from pods running your cluster to the gateway node, and then gateway node is the one that sends to the other clusters. Okay, then another optional component is GlobalNet controller. So the use case of GlobalNet was added a bit later than day one with Submariner. So the use case was, okay, if I'm going to deploy Submariner to connect clusters that are already existing, I will definitely run into scenarios where multiple clusters are using the same CIDR, right? Like most people, when you say they deploy with, say, Kubernetes, they will have some default CIDR that every cluster comes up with. And we found out most of the folks were actually using those default CIDRs, which means they had multiple clusters, but all of them using same CIDR. And when you provide a flat network connectivity, that's not going to work. Okay, so we came up with something called a global CIDR. So we have this address space 169.254.0.0/16 range, to which and whenever you join a cluster, it gets a subset of this CIDR range. And when any service or a pod requires access to a service or a pod that is cross-cluster, it is given an IP from this one, from this edge, and that is what is used for communication. So basically, like I said, normal submariner, when you connect clusters, if there are no overlapping CIDRs, then yeah, it's a flat network. Anyone can talk to anyone. But if there are overlapping CIDRs, because that communication is not possible, so that's where GlobalNet comes into picture. And in this case, you cannot talk to every other pod, but only the ones that you designate that you want to have access to. So user can give a differentiator if you want, like for some reason you're using 169.254 in one of your clusters and it does not work for you, you can specify a differentiator that is supported. Another thing that you can do is you can specify the size, of the area chunk that you want to allocate a cluster. Like you may have different clusters of different sizes. It does not make sense to give a /24 to each one of them. Some may have lesser number of pods that you need, some may have more number of pods, so you can control that also. Okay, and as I said, every service in pod is given IP, but we plan to change it for scalability reasons because it will not scale up very well. Because as you can see, it's a 2⁻16 IP address limit, and you can run into it pretty quickly. So that was Submariner, the connectivity. I'm not going into too much detail because that's not the focus of this one. But if you want, we can have a separate session that goes in depth into it, or you can look at the website. Link will be at the end of the slide deck. Lighthouse.
Just
Lighthouse,
to recap before we move on.
Yeah.
Just so I'm clear, so when it establishes tunnels, everything goes through the broker cluster. Is that correct? So there's not
no
between each
the
cluster.
Broker cluster is just for the control plane, not for the data plane.
Okay. So the data plane is each cluster connects to every other cluster.
Yeah. So that's more of a full mesh as of now. So we have plans on the roadmap to kind of improve it further so it scales better. But as of now, it's like a full mesh between the clusters that join Submariner.
Great.
Okay. So Lighthouse is a sub-project of Submariner that provides service discovery. Maybe I'll come back to the diagram later. Just go to the talking points first. So it, as of today, works with Submariner. We use it with Submariner, but we have designed it in a way that it can work with other connectivity solutions. Like instead of Submariner, if you have some other connectivity solution that provides that sort of flat network connectivity with clusters or access to services, then you can use Lighthouse with a few tweaks. If I remember correctly, as of now, the only Submariner specific stuff actually in Lighthouse is where we detect whether the cluster is connected or not. Because when you do a DNS query for a service, which is a cluster IP service running in multiple clusters, you only return IP from round robin if that cluster is actually connected. And same goes for headless service. You don't return pod IPs for pods running in a cluster that is not connected at a given time. I think other than that, we don't have anything Submariner specific. So it has two main components. One is the Lighthouse agent. That's what I was talking about earlier. That's the control component that runs in each cluster. It runs as a replicator size of 1. This is the one that's providing a core MCS API implementation. It listens for when service exports are created. It creates endpoint slices and sends those endpoint slices to the broker to distribute. And it reads from the broker any endpoint slices and imports created by other clusters to create a copy of them locally. So this is where the bulk of the API implementation exists in the Lighthouse agent. And then we also have another Lighthouse DNS, which is a core DNS based implementation, default size of 2. You can change to it. This is the one that handles all the in-cluster queries for the domain cluster set.local. So the way it is done is you already have a core DNS running in your cluster. We use the forward plugin to forward any queries for cluster set.local domain to the Lighthouse DNS over here. So this is it. So let me just get back to the architecture over here now. Okay, just give me a second. I think I'm running low on battery. Just give me a second. All right. So this is an example, like we have two clusters, one is west and east, and they are connected to submarine or is indicated by this encrypted tunnel that goes over internet. So the way is there's a service A running on east. So when you create a service export, the Lighthouse agent will listen for service export creation and look at the endpoints and then create an endpoint slice and service import, which will be then distributed to the broker, and then the Lighthouse agent over there from the broker will pull that copy locally and it will be available in its local DB. Now when the pod over here in the west tries to query for this service using cluster.local, it first goes to the core DNS, and core DNS has a Lighthouse plugin that we have written, and which forwards the query for any services, for any queries with cluster.local in the FQDN to the Lighthouse DNS, which reads the service import and endpoint slice information to return the IPs. So that's the basic gist of it. And as you see over here, in this case, the broker is running on West cluster. It can run on any of the data clusters that you are running, or it can run on a totally separate cluster if you want, which is not running data. That's up to you. So because it's basically just, like I said, the DB using Kubernetes API endpoints, right? So where we are in terms of implementation of MCS API. So as I showed in the demo, you create service export to make a service multi-cluster aware. Cluster IP, headless service, and stateful sets. These are the ones I demoed right now. These are already supported and are working. And it only resolves services which are in. So if you have multiple clusters, it will only resolve services which are in clusters that are connected. I know that in the MCS API we talk about, that endpoint slice have some sort of a TTL or something to detect when it's no longer reachable. Instead of that, because with Submariner we already have cluster connectivity information, and with endpoint slices coming over, we have available. Like if a pod goes down, the endpoint is no longer valid, we kind of update it and it will be removed anyhow. So we are not using TTL and all that stuff. We can look into it if it needs to be used that way, but we're not doing it right now. And so the service import and service export object that we're using, these are not like as defined in the MCCP because we did not have any way to pull it. So we had our own in-house like Lighthouse or submariner.io/service import and export. So which are based on, I think, very early version of the AP that they're not fully updated to the current version, because our plan is once service import and export are available in Kubernetes, and, I remember we have a repo for API, then we'll use those and move to those. So it's a sort of a work in progress kind of CR that we are using for now, not for the long term. And then as I pointed out, we don't use supercluster IP yet. It is to be done. So our plan is once we move to service import and export, what is the Kubernetes, and at that time we'll also look into how we can do the IP allocation without requiring a central controller. And other thing is, like I mentioned, GlobalNet is used for providing support for overlapping CIDS. When you have multiple clusters overlapping CIDS, headless service doesn't work with yet because currently GlobalNet does not support ingress on the pods. So that is also in the works on our roadmap. And once that is available, then headless service will also work with GlobalNet. And the final point is something that spec doesn't talk. I think the spec doesn't explicitly allow or deny it, but because of the way Submariner does things, it was very easy use case for us to support. So we do support it. So idea is you can use cluster as a prefix to your query to get cluster IP or the pod IPs for headless in case of headless service from one specific cluster. So this final point is something which is, I'm not sure if you would call it, is it non-compliance with the spec or not? There's maybe one way to look at it, but because the way Submariner does things, it was easy enough, so we might as well implement it.
Yeah, interesting. That piece, it would be, it'd be good to come back to at some point. I wouldn't say it's non-compliant to have an extra feature, but you're right, it's not in the spec, but it has come up before, but I think mostly around debugging. Like in practical use, I haven't yet heard much demand, but I'd like to be told otherwise for sure.
Yeah. No, I remember I was the one who had sent the mail to the SIG because actually we have someone raise an issue on Lighthouse that they wanted a feature. So it was actually someone requested for a feature. We didn't get the details of why, and we did not push more for that, but we felt okay because it is easy enough for us, might as well.
Yeah, I think it was necessary for multi-cluster cockroach DB setup, right?
No, I think this was from someone else.
Okay. Yeah, I thought it was because of that.
The Cockroach DB use case was support for stateful sets actually. So, but for specific cluster was, I think they were running Kafka instances in multiple clusters, and they wanted to access only in one particular cluster for some reason. So,
Okay.
but yeah.
Yeah, the two use cases I've definitely heard are, of course, I want a single endpoint that returns all the IPs for headless, and then I want to be able to address individual pods throughout my multi-cluster headless service. Those ones are like definitely required. The cluster level addressing, where you return all the IPs within a single cluster, like seems like an obvious middle step, but I haven't yet heard specific demand. But if you have, that's great. We should.
Because besides other thing is, I remember when we were also discussing in the team, we felt that, okay, when we have a full implementation of MCS API, maybe this is something that could be managed in some ways through network policy. Like some of the use cases that we sort of came up with for a cluster specific use case was like GDPR and those kind of policies where you want from a specific zone. We felt that once we have, topology affinity in endpoint slices and maybe even network policies, that might be able to cover this use case. But at least till we have that, this is good enough for middle ground, I think. So people will find it useful for now, at least. So, but I wanted to highlight this, so that if someone is using somewhere, it works for them, they should realize that it may not work with every MCS API implementation unless we document it and capture and make it part of, any MCS implementation should support this also. Okay, so now these are some of the useful links. First one is the project documentation website, which I took most of the material I've used in the slides. You have more detailed architecture diagram, how to use some CLI examples, then the GitHub repository, and of course the Slack channel that we use for Submariner. It's on the Kubernetes Slack, #Submariner. Any questions?
Thank you very much for doing that demo and giving this presentation. It's awesome to see it in action. Andrew's left, but it also, I'd like to circle back. Like, does this kind of solve the use case he's looking for? But yeah, that was great. Thank you. And then my main comment is that, I'd like to circle back on that cluster addressing use case. I think we should probably address something around that in the spec, if it's specifically per cluster headless addressing, or if we want to outline another way of solving the same problem. But we should definitely revisit that.
Yeah, great demo. Thank you.
After the call, I'll send across a link to the slide deck on the mailing list in case anyone's interested in it.
Awesome. That would be great. Really appreciate it.
Or would it be better to just add to the meeting notes? I'm just wondering, what do you think? What would be
meeting notes would be great, but I don't think it hurts to mail the list either.
Okay, I'll do both then.
Awesome.
All right, I think that was the agenda for today. Thank you, everybody. See you next time.
Thanks a lot.
Thanks. Bye.
Bye.
Thank you.